see, okay, now. Yeah, so, well, you did well in the last quiz. It's just that it seems that the uh, there's still some confusion in regard to, yes, in regard to the power rule of exponents. I am still seeing some problems there. So I just want to emphasize really that the power rule of exponents can only be used for a multiplication and division, and not for addition and subtraction. So please note of that, because I saw it in when you tried to factor out what's that? I think you factored out R. Yeah, so it's important to, I just want to emphasize this because it seems to be recurring when we had the R to the 6, something like that, plus 216. You just thought there, well, because this one is a cube root, and so you did r squared plus 6 cube. Okay. R squared plus 6 cube. All right. That's what you did. You extracted the cube root of r to the 6, which is r squared, and then 216, which is 6, and then cube. Please note that r squared plus 6 cube is not r to the 6 plus 216, because that means that the r to the r squared plus 6 cube is, you will have to multiply r squared plus 6 3 times by itself. All right? Yes. So please just note that will only happen if I have 216 r to the 6. Okay. And then that is the same as 6r squared cube. All right? So these are not equal. Okay. So please take note, only multiplication and division that you use the power rule, but not for addition and subtraction. But I think that's the one, and all the rest you've done well, so I'm happy about that. All right. So now we will continue. We learned about the Cartesian coordinate system, and then learned how to find the intercepts. So looking for intercepts, we really would do a lot of solving equations. So before moving on to finding equations of a line, I just want us to have some practice on how to solve equations, because all through the we learned that algebra is actually solving equations. All right. So all of the things we'll be discussing would be most likely solving equations. So I want to, for us to practice before. Yeah. Okay. So there's a question.
Yes, I wanted to ask about the r squared plus 6 and into r squared plus 6, r squared plus 6. Oh, it's from the r squared plus 6 cube. Oh, that's the final answer.
No. So what I'm saying is the final answer, I think I put your, for r to the 6 plus 216. If I want that factored, we call this sum of cubes. All right? So therefore, you extract the cube root of r to the 6, which is r squared. The cube root of 216 is 6. Then the other factor, you remember, you square the first term. If this is a, if the middle term is a plus, this should be a minus, and get the product of the first and the second, and then square the second term. This one would be our factor for r squared, r to the 6 plus 216. So what I'm saying is this is wrong, because r squared plus 6 cube is not equal to r to the 6 plus 216. R to the 6, r squared plus 6 cube means you multiply r squared plus 6 3 times by itself. So this is, they are not equal. So what I'm saying is, if you're dealing with power rule of exponent, that only happens when it is a product rather than a sum. All right? So when that is r to the 6 times 216, yes, you can use the power rule, but not r to the 6 plus 216. Is
Yes,
that okay
yes.
now?
Now it makes sense because you have done you have factorized. You leaving it like this, I was confused. Like r squared plus 6 times r squared plus 6 times r squared times 6. You left it like that. So I wasn't
Yeah,
sure.
yeah, okay. I am only saying that when you said that r to the 6 plus 216, the factors are r squared plus 6
And
cubed. That's wrong because r to the 6, okay, let me erase the other thing so that it will be clear. So I'll erase that. So I'm saying that r squared to the 6 plus 6 cube is not the same as r to the 6 plus 216. Rather, r squared plus 6 quantity cube would be equal to this, to r squared plus 6 times r squared plus 6 times r squared plus 6. There. So I'm saying this one is equal to this, but not equal to that one. So this is only, I am saying that r squared plus 6 raised to the third power, this is the meaning of that, and not r to the 6 plus 216. So the factors of r to the 6 plus 216 is r squared plus 6 times r to the fourth minus 6r squared plus 36. Did I make myself clear? So I'll erase this now so that that's not the, we're now saying, okay, so let me erase this. Okay, this one, there. Okay. So the factors are r squared plus 6, r to the fourth minus 6r squared plus 36.
okay.
Okay, all right. Thank you for that question. Okay, so let us proceed. We'll talk more about equations, and then after that, we will learn how to find equations of a line. Okay. All right. So the first thing, of course, when we were looking for intercepts, we have linear equations in two variables because we now have y is equal to a mx plus b. We'll go back to that later on, but just have practice. We'll now have practice on solving equations in one variable. And so that means that we will have to just solve for the value of x. All right. So yeah, let me just, okay. Now, so when I have the linear equation in one variable is of the form ax plus b is equal to 0. And then, yeah, sometimes it can be not equal. It can be another constant term or something like that. But that's the main thing of linear equations in one variable, where you have the coefficient of x and a constant term. And then we solve for x. Now, there are different types of equations. One is identity, an equation that is true for all real numbers. You know, sometimes you have an equation where any value will make that equation correct. So an example of that is 3x is equal to 2x plus x, which is actually reflexive, you know, where we're saying if you have the equation 3x is equal to 2x plus x, any x that you put would always be correct, because really 3x is equal to 3x. So just to give you some types of equations, another type of equation is conditional. That is an equation that is true for at least one real number. So if you have that example of 5x plus 2 is equal to 3x minus 6, what do you think is a solution to that problem? Okay, this one. Okay. Give me a solution to 5x plus 2 is equal to 3x minus 6.
Group the like term
Huh?
times 3. Transport 3 to the left side. Like 5
Okay.
x minus 3 is equals to minus 6 minus 2.
Okay, and then?
And then it will be 2x is
All
equals
right. So now solving this equation, that's what you're saying. So you say 5x, you transfer 3x to the other side. And you know what? Why we have to put a minus here? Because we're subtracting 3x there, so that 3x will be 0, right? And you say is equal to minus 6 minus 2. So saying that when you transfer to the other side, it will become negative, but the principle really is because you are subtracting 2 on one side in order to make 2 minus 2 equal to 0. And so here you say 2x is equal to minus 8. So your x is equal to negative 4. Okay, so negative 4 is a solution. So we call it conditional, that this equation will only be true if x is equal to negative 4, which is true when we try to substitute 5 times minus 4 plus 2 is equal to 3 times minus 4 minus 6. So this is minus 20 plus 8 plus 2 is negative 18. And then 3 times negative 4 is negative 12 minus 6 is also negative 18. So it's conditional because the only time that equation is true is when your x is equal to negative 4. Yeah, so that's why we call it conditional. And the other type of equation is inconsistent. Inconsistent when an equation is not true for any real number. It will never be true. And I think all of us would know that, yeah, if you solve this problem, you now have 5x minus 5x is equal to minus 20 plus 15, right? If we transfer both sides, this is 0, this is negative 5, and they will never be equal. So there are equations that would be considered inconsistent. We'll have more of these kinds of equations maybe later on when we solve some problems where we say there is no solution on that. So we call that inconsistent. So I just want to give some types of these equations. So let us now, practice or remind you, you have done this in the past in your high school algebra. We solve linear equations in one variable. So the first problem there is, easy one, 2x plus 7 is equal to 19. Answer.
X is in
Okay, yeah, that's an easy one because you just say 2x is equal to 19 minus 7, right?
sorry.
Okay, and so you now have 2x, 19 minus 7 is 12.
12.
So therefore, x is equal to 6. So it's always good also to substitute, check if the answer is correct, because sometimes you may have written, you were thinking of 6 and you wrote a 5, okay? Sometimes that happens. So it's good to substitute. So when you substitute x, instead of x, it's 6. So 2 times 6 is 12 plus 7 is equal to 19. All right, that's an easy problem. And you can even do it mental math. This one, I think you can do mental math.
Yeah, minus 1, minus 10.
Min-
X is minus 5.
All right. So there, x is equal to minus 5. Good. No problem. And again, you substitute. Minus 5 times 2 is minus 10 plus 1 is equal to minus 9. All right. How about this one?
Oh,
Can you do mental math here? All right. I think it's good to remember. We'll now learn, what we have learned previously when you now can do the multiplication, use distributive property, and so on. Okay. Yeah, a little bit. Yeah, you need some paper and pen for us to solve number 3. Okay, maybe let's do this together. So we now have distribute 4. You have 4x minus 12 plus 1 equals 15 minus 5x minus 30, right? Okay, then we'll just simplify first the left side. 4x minus 11 is equal to, let me have the x first before the constant. 15 minus 30 is negative 15. Okay, then we now do that. We call it transposition. Yeah, that's what they say. Algebra is a science of transposition. Okay. So 4x plus 5x is equal to minus 15 plus 11, right? Okay, so your answer here will be 9x is equal to,
-4.
all right, yes. Final answer, minus 4 over 9, because we divide both sides by 9. Okay, so x is minus 4 over 9. Yeah, you can substitute, but that one would mean it's, it's fractions. Yeah. But all right, so we have these kinds of equations where we'd have different we have some binomials that you need to simplify first. Okay. All right, try the number 4 for your short practice before we have more examples.
No.
Do number 4.
Yeah, everyone is getting sick.
Mhm.
Got it?
Okay.
It's minus.
Answer.
I got minus 11 by 5.
Ah,
Hmm?
got minus. I know, I got
What's your
This is
answer, Sane?
3.
this one.
-3, I think.
Okay, so you said -3.
I
You can
also got
How about you,
-3.
Bethany?
I also got -3.
All right, -3. So please just do some checking of what of the work. Okay, let me erase all ink on the slide so that we can, yes. All right, yeah. Okay, so maybe you can check your work, Manesh. Maybe you just had some little mistake on your signs. Okay, so this is actually minus. Sorry. Okay, minus 6x plus 2. All right, plus x equals 14 minus x. So sometimes you would say there's an x at one side, there's another x at the other side, but take note that they have of different signs. So don't say that one you can cancel because it's equal to 0. Okay, that should not be. So actually we now have 5x minus 5x if you add minus 6x plus 2. Okay, plus 2 just to do it step by step. Then minus 5x plus x is equal to 14 minus 2 gives you minus 4x is equal to 12. Therefore, x is equal to minus 3. All right. Divide both sides by 4. Negative 4. So I hope you saw where you Manes, what happened? Why was your answer?
So minus 2 times 3x minus 1 plus 1 I wrote instead of plus.
Okay, yes, instead of plus x, that's it. Yes. So sometimes we make mistakes copying or what. So that's why I'm saying it's good to check. You think, well, I did it correctly, so check whether your answer is correct. And that is actually, you can do the checking and you'll find that the equation is correct. All right. Now, let's try another set. This time, a rational equation, just for us to be reminded of our getting the LCD, all right? So when I have 7 over 2x minus 5 over 3x is equal to 22 over 3. First thing that you'll have to ask yourselves, we want our denominators to be the same so that we can add or subtract. So our denominators are 2x, 3x, 3. What would be your LCD?
Yeah. Uh,
1.
What will be the what expression or what monomial will be divided by 2x, 3x, and 3?
3x.
Yeah, I'm thinking like that.
But
3x,
can 3x be divided by 2x?
No.
6.
No. Mhm.
Oh, yeah.
What do you
6.
think?
Oh, it's
So you have a 2 and a 3, all right, and an x. What can be divided by 2x, 3x, and 3?
6x.
All right. So your LCD will be 6x.
mm, wait, what's LCM?
Lowest common
Or
denominator.
LCM. So your LCD, LCM, they are the same. Okay, the least common multiple is the same as the least common denominator. So what do? We're now saying we want to, okay, so 7 over 2x. We want this to be 6x. So we multiply this by 3 over 3, right?
Mm.
Okay. Minus 5 over 3x. We want it to be 6x. So it will now be 2, or we multiply by 2 over 2. And then 22 over 3, we also want to have the same LCD, all right? So we multiply this by what? 2x over 2x, right? So that all of them will have 6x as our denominator. All of the denominators should be the same. So you now have 21 over 6x minus 10 over 6x is equal to 44x over 6x. So all of the denominators are already 6x.
Mm.
All right? So in that case, we want to get rid of that denominator. All right. So in other words, we can now actually, if we multiply both sides by 6x, then all denominators will be gone. All right. In other words, I multiply this. What you do on one side, do it on the other side. So I multiply this by 6x. I multiply this by 6x. They will still be the same because we're multiplying by the same monomial. But we should remember it's always important that when we're dealing with a rational equation, I think you know the principle that you can never divide by 0. So you would say that in this equation, you will say that x should never be equal to 0. Of course, your x will not be 0, but just to show people that, just to know the principle that we cannot divide by 0, so that we can only do all this when your x is not equal to 0. So yeah, this may not be a solution, but just in your mind, you know that x will never be 0. Okay? So anyway, if you do that, then your equation will be as simple now as 21 minus 10 is equal to 44x, right? Because 6x, 6x, this 6x will cancel all of them. So what will be your final answer? 21 minus 10 is 11, right? 44x. So what will be x?
4.
4. Okay. So go through it and then please just ask questions.
No different.
Yes. So x is equal to 4.
So how is x equal
Hmm?
to how is
Yeah.
x 4?
Say that again.
How is x equal to 4?
Oh, I'm sorry. That should be 1/4.
Yeah.
Okay, thank you. Thank you for that's it over 40. It will tell you. Thank you, Manish. It should not be equal to 4. All right. So it's 11 over 44. Oh, sorry, it's not even, it's not 4. It's 11 over 44. Okay.
Which will
There's
be,
okay, and then there was common.
then just simplify it, right?
11 over 44. You can divide 11 by 11. So it's not 4. It should be 1/4, right? Tell you. Thank you. Okay. Yes. It's 1/4, not 4. Are we okay? So 44 can be divided, can be divided by 11. So 11 by 11, so you now have 11 over 44. You can divide this by 11. You can also divide this by 11. So 11 by 11 is 1. 44 by 11 is equal to 4. So answer is 1/4, not 4, not 4. Yeah, that one is a, you looks like it's just a 1, but it's again the idea of the importance of little things. Okay. So the answer is 1/4. Thank you, Manish, for seeing that. So x is equal to 1/4. You can also do the checking, which means that, yeah, instead of x, we substitute 1/4. So you will now have 7 over 2 times 1/4, 5 over 3 times 1/4, and then equals to 22 over 3.
Mm-hmm.
Mm-hmm. 7 over times 4 over 4, 28 over 4 minus 10 over 12, 1/4 to 120 over 12. Okay, and I think we now have,
Why would you? It's blood.
yeah.
You'll get
Is
infections
that
in
okay
your.
now? X is equal to 1/4? Mm-hmm.
Ah, my. Ah, what do
All right. Let's try another problem so that we can. All right. Here. 2 over 3x equals 1/4 minus 1 over 6x. Will you please try that?
1/4 minus. Okay, LCM.
Yes. What's your LCM?
Is it 12x?
Okay. Yes.
Can
Yeah,
you?
because you have 3, 4, and 6. And the monomial that I call it monomial rather than just a number because there's already a variable. The monomial that can be divided by 3x, 4, and 6x is 12x. All right.
Mhm. Mhm.
Mhm.
Yeah,
Okay.
looking at the dome.
No?
You got it?
I'm trying to do the first one in different way so that I know that I can continue with it.
Which way?
Okay, what's your answer?
Okay.
Oh, let me do it. Have you done it?
No, no. I got
Answer. What did you get?
10 by 3.
Okay. 10/3. Bethany, you
Mm.
get the same answer?
Yes.
Okay.
X minus
Rachel?
Seems exhausted.
Sine,
1.
same answer?
I was trying
Okay,
to,
yeah, figure it out.
I was trying to wait to see if
Which way
it
again?
works. I was still figuring out the first one on it in a different way.
Oh, all right. Yeah, maybe one way if you really want not to anymore multiply by this and this and this, I usually would have, if you divide 12x by 3x, you get a 4. And then multiply by 2. You get that? So instead of multiplying 4/4, you would just say, well, if I divide 12x by 3x, it will be a 4 and I multiply by 2. So it means it's the same as I'm multiplying by 4/4.
Yeah,
Yeah. So actually, you immediately can say 12x by 3x is 4 times 2 is, that becomes 8/12x. Yeah, because I multiplied 2 by 4. And multiply
exactly.
3x by 4. So I'll get 12, multiplying by 4/4. Yeah, and then sometimes we'll say 12x divided by 4 is 3x times 1.
Yes,
Okay. Yeah, so this one will again be 12x. I multiply both by 3x and 3x. And then minus 12x divided by 6x is 2 times 1 is minus 2/12x. That is the same as multiplying the numerator by 2 and the denominator by 2. And knowing that x is not equal to 0 here, then this whole thing can just be if I multiply both sides by 12x, all of this will be eradicated. So we'll just have 8 is equal to 3x minus 2. 8 plus 2 is equal to 3x. So that 3x, I can just put the 3x here. It's the same. 10. So x is equal to 10/3. So it's actually the same process. You just multiply both numerator, denominator by a number that will make the denominator the same. And for you to be able to do that, you divide the denominator. Okay, use the denominator as a divisor of your LCD. So 12x divided by 3x is a 4, and that will be your multiplier. 12x divided by 4 is a 3x, that will be a multiplier. And 12x divided by 6x is 2, that will also be the multiplier of your numerators.
Mm.
Okay, let's have the other one. This one. I think with that, you can already do all the answers correctly. Okay, the 3 and the 4. It's for practice. That one is a little easy.
So I have a question for 3.
Yes.
I can how I'm still confused with finding the LCM, the
Okay.
LC.
All right. So you have x, 2 and
Yeah.
2x, right? Yes. So the least common, the least value, the least monomial that can be divided by x, 2 and 2x. What will it be? Isn't it 2x?
Yeah,
Yes.
I was doing number 4.
Yeah, number 3. It's number 3. Okay.
but so it's 2x.
Yes,
Okay.
that's your LCM.
Hmm.
It's 2x.
Yes, it's 2x.
Hmm.
What's the answer?
I get it.
Hmm? Okay, let me
Uh,
erase so that I can proceed. Okay. So we said that the LCM is 2x. LCD or LCM. Okay, Bethany, what did you get as your answer for number 3?
-1.
-1. Mm-hmm.
-1 also.
Yes. Okay. It's supposed to be -1. Yeah. So if you want to follow the rule that to have all the denominators the same, okay, the multiplier 2x so I'm dealing with number 3. 2x divided by x is 2 times 2 is a 4. So you are multiplying this by 2 and 2, okay? Minus 3, 2x divided by 2 is an x times 3 is 3x. So you are multiplying your 2 by x over x equals, okay, 2x by 2x is 1. This is now, okay, 7 over 2x. Yeah, you don't have to do anything there because the LCM is already 2x. So all the 2x's will be removed. Knowing that, okay, your x is not equal to 0. So minus 3x is equal to 7 minus 4 gives you 3x is minus 3x is equal to 3. X is equal to minus 1. It's okay? All right, number 4. What's LCM for number 4?
Can you be 2x?
No. The LCM should be always greater than or equal to one of, you don't have an LCM that is smaller than any of those denominators. You now have x, 10, 4x.
And it's
so it cannot be 10. Like it
14.
cannot be less than 10.
Yes, it should not be less than 10.
But it can be 14.
Okay, so you now have a 1, a 10, and a 4. Oh, definitely, you are dealing with first the numbers, okay? 1, 10, and 40. What number can be 4? What number can be divided by 10 and 4? Answer.
40.
Is there a lower number than 40 that can be divided by 10 and 4?
20.
All right. 20. Yeah, one way of doing that is anyway, this one can just be in your intuitive thing, but we're saying 10 is 5 times 2. 4 is 2 times 2. So you remember we're saying by the order, this is considered to be, yeah, 1 or by 2. So 5 times 2 times 2 is 20. 5 times 2 times 2. So 20 is your LCM. 20. And there's an X, so it will now be 20X. Okay. All right, so LCM is 20X. I think you just need a little more practice, but the principle, I am seeing you to be getting it well. Has an answer?
I got 35 divided by 2.
Okay. Bethany, get the same answer?
Yes.
Mm-hmm.
5 over
Rachel, you're okay?
35.
No,
35
yeah,
over 2. Sine, okay?
35 over 2.
All right. So just to show it, we now say that our LCM is 20x. So this, the 1 over x will be 20 over 20. So I multiply 20x divided by x is 20 times 1 is equal to 20. All right. 1 over 10 is 2. 20x divided by 10 is 2x over 20x. So you are multiplying by 2x over 2x. Minus 20x by 4x is 5 times 3 is 15 over 20x. So they now have the same denominators, all right? So I multiply both sides by 20x, okay? I will now have 20 is equal to 2x minus 15. So we'll now have 20 plus 15 is equal to 2x. So x is equal to 35 over 2. Good. All right. And then last set of examples here before I move on to now dealing with equations of a line. This time, when we have binomial in the denominator, you have done this previously. The only thing now is we're introducing equation, okay? But you have done adding, you know, in our last exam, and you did well. You're adding rational expressions. So we now have, there is now a binomial now. So one nice thing about one thing that you'll have, especially for number 1, you know that x minus 6 and x, you don't have any common factors. So just the knowing the principle, the easiest way to do it is to do what we call cross multiplication. Yeah, we cross multiply. But here, we just say we can do that only if x is not equal to 6. Reason, okay, maybe I'll change the color so that, okay, let me just erase all of them. I'll change my pen to red so that you can still see. Yeah. I'm saying that in this situation for number 1, you are in your mind, you say, well, x should not be equal to 6 and x should not be equal to 0. Reason is because if x is equal to 6, the 3 over x minus 6 will be 0, 3 over 0, and that cannot happen. And then if x is equal to 0, x will have 5 over 0, which cannot happen. So knowing that x should not be equal to 6 and x not equal to 0, as I was saying, the easiest way for number 1, and if that is your problem, you just cross multiply. You just say 3x is equal to 5 times x minus 6. It's just one way of saying that I multiply 3 over x minus 6 by x over x. And then I multiply 5 times 5 over x by x minus 6 over x minus 6. And so you can just actually do cross multiplication. So some shortcuts kind of thing. So you now have 3x is equal to 5x minus 30. So now you have 3x minus 5x is equal to minus 30 minus 2x is equal to minus 30. X is equal to positive 15. So that's what it is for number 1. Okay, with that idea, will you please solve number 4? Because they are almost of the same procedure. So when there is nothing that you have something in common, do number 4.
Seven.
Uh-huh. Over exactly 7.
Is that wrong?
Yeah, 7 is the okay, because you now have minus 9x minus 3, right? Equals 8x plus 4. So you
Yes.
have a minus x on one side and 8x on the other side. If you transfer 8x to the other side, what will it be?
Minus 17.
All right. It will be minus 17. Okay?
It's gonna be
Yeah, because you know there is a temptation that you say one is 9x, the other is 8x, that it will be equal to 1. But one thing is, one has a negative value, negative sign, the other is a positive sign. So you know that when you transfer to the other side, it will become a minus. And so it will become minus 9x minus 8x. So it's minus 17x
yes,
is
it's
equal to 7. What's the final answer?
7 over 17.
What's the sign? Positive or negative?
It's negative.
Okay. All right. Yeah. So now, as I was saying, we do cross multiplication. We now have minus 9x minus 3 is equal to 8x plus 4. Minus 9x minus 8x is equal to 4 plus 3. Minus 17x is equal to 7. X is equal to minus 7 over 17.
Yeah.
Okay, yes. So minus 7 over 17. All right. Now, when we have, not only the one monomial one side, another monomial other side, there's now these combinations like x over x minus 3 equals 5 over x minus 3 is minus 1/2. In a situation like that, especially that you're seeing that you have the same x minus 3 and x minus 3, you simplify first, okay, by putting together. Let me erase. All right. Yeah. So you first begin with x over x minus 2 minus 5 over x minus 2 is equal to 1/2. Put together the ones with the same denominator. So that is a little easy, okay? So this is actually to be written as x minus 5 over x minus 2 because they have the same denominator. And so you can combine the numerator is equal to 1/2. And then, you now can do the cross multiplication. Well, of course, if they are of the same different denominators, think of what you have done in the past on adding and subtracting. So cross multiplication, you now have 2x minus 10 is equal to x minus 2. All right. Although, of course, you will say this only happens when x will not be equal to 2 because if x is equal to 2, x over x minus 2 and 5 over x minus 2 will be having a denominator which is 0. So you now have, okay, x minus 2, 2x minus x is equal to minus 2 plus 10. So you now have x is equal to 8. So this kind of equation, you will, oh, I'm sorry. I am doing number, okay, x minus 3. Okay, I think I am doing number 3. And I am almost the same as number 2 anyway. Yeah, I'm doing number 3. So x over x minus 2 equals 5 over x minus 2 minus 1. So I think for number 2, you can just do that. It's almost the same, except that I am having a denominator, which is x minus 3. Will you please just do number 2? The problem is just the same, except for my subtrahend as a 3 rather than a 2. Oh, because I think I put equals 1/2. Let me make this a plus. So I don't anymore change my solution. Another thing, the eyes, sometimes you see it as, instead of a minus, you put it as a plus. So number 3, I am changing my problem to suit my answer. Okay, so I'm making it a plus, but in number 2, let that be minus. Okay. Sorry for that. Please just do number 2, so then you can. Answer.
Negative thing is very confusing.
Bethany, you got the answer for number 2?
Not yet.
Okay. Manish, what's your answer?
I got 7, but I'm not sure.
Okay. Sine.
It's gonna be, let me see. It will be
Rachel, do you have an answer?
13, 13 over 3.
All right. I think the answer should be 13 over 3. Okay, check your work. Manish, and see where did you go wrong?
Um, so when you call cross multiplying and you
Yeah.
have leave 1/2, so
Okay.
negative sign confuses me.
All right. So I think that negative sign, it's either you do that for the numerator. Yeah, the numerator. I always
Mm,
would want, whenever I have a negative sign in a fraction, let that be the sign of the numerator, so that you don't get confused. Only the sign of the numerator, not both, right? It's only for one of them. Yeah. All right. So I think you did what you have done. All right. You say x minus 3 minus 5 over x minus 3 is equal to minus 1/2. So you got x minus 5 over x minus 3 is equal to minus 1 over 2. So to always do that, so that you don't just get confused. Make
mm,
the sign, put that in the numerator. Yes. So 2x minus 10 is equal to minus x plus 3. So that 2x plus x is equal to 3 plus 10. And therefore, 3x is equal to 13. X is equal to 13 over 3.
yeah.
All right. So Bethany, is that all right too? It's okay?
Yes, it's good.
All right. Okay, yeah. So these are some exercises on solving equations in one variable. I'll have more. I'll give you some exercises to do, so then I can also give you feedback. So last meeting, we talked about the intercept. Let's now go to equations of a line. After having learned how to solve equations, we'll move on to learning how to find the equation of a line. But it's important to understand that there are different elements as far as a line is concerned, the graph of a line. One of them is the intercepts, where you have now the x-intercept, the point where the graph passes the x-axis. And you have now the y-intercept, the point where the graph passes the y-axis. Besides intercept, and I think this was hinted to us by Manish last meeting, that you're also dealing with what we call slope of a line. And this is a measure of how steep the line is. We call it slope. And it is dealing with what's the ratio between the vertical chains, which we call the rise, this one, to the run. Okay, we call it to rise to the run. So that mathematicians decided to make a formula for the slope of the line, where we say we want to compare the change in y with the change in x. And yeah, when you really deal with calculus, this is a very important, if ever, maybe you will not take calculus, but this is a very important concept. The change in y over the change in x. So that for us to be able to find the slope, you need 2 points to begin with. And then get the distance traveled from y1 to y2. And that will be, of course, y2 minus y1. And how much had been moved from along the x. And that will be x sub 2 minus x sub 1. And so this is now our formula. To find the slope, you subtract y2 minus y1 divided by x2 minus x1. With, of course, a very important restriction that your x1 minus x2 should not, where x1 should not be equal. This is not equal. All right. Should not be equal to 0. Your x1 minus x2, because we don't want that to be 0, because if it's 0, then we will now have a 0 in the denominator, or x1 minus x2 or x2 minus x1 must not be equal to 0. Okay, so let us proceed. So this is now just an example. If my line passes through 5, 1, and 3/4, those two are actually already your what's that? So this side here, okay? Yeah, from 5, 1, 3/4. So having 5, 1, and 3/4 as 2 points, you can make a straight line out of that. So for you to be able to find the slope, let us, if our point 2, sorry, my pen fell. If this is my point 2, and this will be my point 1, okay? So we now we begin with the y coordinates. So the change in y is 4 minus 1. The change in x is 3 minus 5. So 4 minus 1 is 3. 3 minus 5 is -2. Therefore, the slope is -3/2. So what it means is that for every change, two units change in x, there is a 3 units change in y. Okay, so that's the meaning of that. But the thing is, as the change in x, as x goes to the right, it tells us that from point 2 to point 1, it goes down. Okay, that's why it is negative. All right, so this one goes down, this one goes to the right. So that's just a simple example of finding the slope. So let's just practice with using our formula to find the slope of the line, because we will be using this in finding the equation of a line. All right. So have now, if you have -3 and 1 and 1, 5, what will be the slope? So minus
y2 minus y1.
yes, my y2. Let me put this down here. Okay. So this means that it's -3, 1,
4, 4,
and 1, 5.
x2,
Hmm.
1
What
minus
is you
four.
said
So I would always put this as 0.1, 0.2. Actually, it doesn't matter as long as you are consistent with the subtraction. But always put 0.1, 0.2. Okay? So our slope is denoted as m. So you begin with the y coordinates. So it will now be 5 minus 1 over 1 minus -3. Okay?
4/4.
So 0.1, 0.2. So it will now be 4 over 4
4.
gives you 1. In other words, for every increase, or for every change of 1 unit along the y-axis, there's also a 1 unit change along the x-axis. All right. So actually that line is this. Okay, anyway, yeah, that line. Yes. So the slope is 1. All right. And number 2.
-1 minus 5.
Okay, -1 minus 5 over
4 minus
4 minus -2. So it's 4 plus 2, right?
oh,
So what's the final slope?
-1.
-2 minus 2, 5. That's the point. And then 4 minus 1 here, right? Okay. -2, 5, 4 minus 1. So those are the points. Find out what is your slope?
-6/6.
Which is equal to
-1.
-6/6, right?
Yeah.
Is +1 or -1?
-1.
All right. So the slope for number 2, you say -1 minus 5 over 4 minus -2 gives you -6 over +6 minus 1. It's also -1. The difference is that one rises to the right, the other would go to the left, would rise to the left. The other one is rising to the right. So this tells us that it depends upon the sign of your slope. If your slope is positive, then it will rise to the right. If your slope is negative, then it will rise to the left. So that's one way of imagining whether it is rising to the right or rising to the left. Okay, how about number 3? Okay, do it by, we can do it by mental. 0 minus 0 is 0. Anything you divide by 0, what will be, anything, 0 divided by anything will be what?
0.
0. All right. So you have now 0 minus 0 divided by 2 minus 4. Anything 0 can be divided by anything is equal to 0. So the slope is 0. Now, how does it look like when the slope is 0? What kind of line is it?
Is it a straight?
-4, 0 and 2, 0. Okay, this one is the line, right? So it is horizontal line, right? So when your line is horizontal, the slope is 0. Reason is because there's no movement along the y-axis. Okay, so the slope is 0. Regardless of how you move your x, your y doesn't move anywhere. Therefore, the slope is 0. How about number 4?
6 over 0.
6 over?
0.
Yes, it's 6 over 0. Now, what do you say about that? Supposed to be, we're saying your denominator should not be 0, but I think all of us know that when you divide anything by 0, that is an infinity, right? Yeah, we call it infinity. Now, how does the line look like where your m is undefined? We call it undefined. What kind of line is that? Putting your, because it says it is 0, -5, right? And 0, 1. So the line is vertical, right? So when the line is vertical, the slope is undefined. Because now your x doesn't move anywhere. So now the ratio, okay, will have a 0 at the denominator. So these are now some important picture of a line when you know the slope. If the slope is positive, it rises to the right, okay? If the slope, let me erase everything so that you see all right. If the slope is negative, it's downhill. We call it downhill, all right? Because it rises now to the left. If the slope is 0, your line is horizontal. But if your slope is undefined, all right, or we call it infinity, the line is vertical. So if I give you signs of slopes, immediately you can tell me how the line looks like. Okay, so I think those are slopes, and that's just the formula on finding the slope. Okay, so let us now proceed. Okay, and so this is now what you're saying, Manish, last time. That given a line, equation of a line, you can find the slope and the y-intercept. Yes, so this is what we are saying, that the line has a form called slope-intercept form. So if I have an equation which is of the form y is equal to mx plus b. Okay? Where in that situation, your m, which is the coefficient of your x, is your slope. And the constant is your y-intercept. Why is it y-intercept? Reason is if you set x is equal to 0, yeah, your y is equal to b. So b is the y-intercept. Okay. So here, if I have an equation y is equal to 2x plus 3, then immediately you know that your slope is 2, right? And your y-intercept is a positive 3. So in this situation, like I have different equations here. Okay, here, this one. Your slope is minus 3. And it passes through negative 2. So that's your y-intercept. So whenever your sign is negative, then it is downhill or it rises to the left. This equation, y is equal to 2x plus 1, which this one is the graph. Your slope is 2 and your y-intercept is a 1. That's why it passes through 1 here. This equation y is equal to 1/3 x plus 2. Your slope is 1/3 and your y-intercept is a positive 2, this line. All right, it passes through 2. Okay, so those are now some examples. So once you are given y is equal to mx plus b form of a line, then you know the slope. You can find immediately the slope and you can find the y-intercept. Okay. Yes. So that's now a point y-intercept, slope-intercept form. Now, you can also find the equation of a line if you know one point and you know the slope. And we call this point slope formula. Y minus y sub 1 is equal to mx minus x sub 1. Now, take note that the equation of a line will always just have y is equal to, yes, y is equal to ax or mx plus b or whatever is that. Where your y and x, all right, should be retained there, and then your a and b would be some constants kind of thing. Now, I think the point slope form was only taken from the formula of the slope, right? Because the formula of the slope instead of y to y1, because you only know one point, all right? So the slope is actually just the same as y minus y sub 1 over x minus x sub 1. So using the formula of a slope, you can find the equation of a line if you know one point and you know the slope. So that it will become clearer, let me just give an example for that. All right. So I'll use my pen to be okay. Yeah. Right. So this is how it is. Y minus y sub 1 is equal to mx minus x sub 1. So here, if I am given a slope of 3 and a point 110. Then the question is, what is the equation of the line? So from the formula, you have y minus y sub 1 is equal to mx minus x sub 1. We just substitute the points and the value of the slope. So your y1 is 10, your slope is 3, your x1 is 1. So you now have y minus 10 is equal to 3 times x minus 1. But we need to simplify that. And so simplifying, you now have y minus 10 is equal to 3x minus 3. So y is equal to 3x minus 3 plus 10. So y is equal to 3x plus 7. So we'll put that as our equation of a line, where you know that your slope is 3 and that it passes through 7. Okay, so with that, then we now can find the equation. So given us point and the slope, you can solve for the equation, or you can find the equation of a line. Let's proceed. Okay, so just another solution there. I now have the line with a slope of -3 that passes through 0.48. So you just have to substitute. So substituting, we now say y minus y sub 1. Instead of y sub 1, we substitute 8. Our slope is -3. Okay? Our x sub 1 is 4. And so y equals -3x minus plus 12, and yung plus 8 there, so plus 12 plus 8 is equal to 20. So your equation now will be y is equal to -3x plus 20. Okay. All right. Do numbers 1 and 2. I think that one is just substituting to our equation.
Oh, which one?
Number 1, this one, write the equation of the line with slope m is equal to, okay, I'm talking about this and this. Those are two practice exercises. So what's your equation for number 1?
Y is equals to 4x minus 7.
Okay, so you have y minus 5 is equal to 4 times x minus 2.
For number 1 is what?
Yeah. So is that for x minus 7?
7. Is that correct?
Okay, so you got y minus 5 for 4 times x minus 2. So you have a 4 times minus 2 is minus 8. Then you transfer your 5 to the other side. Look at it again. Bethany, what's your answer?
Oh, it's 8. 8 minus 8 plus 5.
Okay, yes.
Minus 3.
Okay. Manish, what's your answer?
Yeah, 4x minus 3.
Okay, so, all right. So actually what you have done is you say y minus 5 equals m is 4x minus 2. So y is equal to 4x minus 8. Transfer 5 to the other side. Y is equal to 4x minus 3. Yes, good. Number 2.
Y is equals to minus 1 over 2x plus 5.
Okay. Yeah, just
No, it's plus. It's minus.
Minus what?
It's minus 1. Minus 1.
Minus 1 over 2x minus 1.
Minus 1.
Okay. Okay. Put it as of the form y is equal to a coefficient x minus a constant. So you got y is equal to minus 1/2 x minus 1?
Yes.
Yeah. All right. So just to put it there in perspective here, you say y minus minus 3 is equal to minus 1/2 x minus 4. Okay. So you get y plus 3 equals minus 1/2 x plus 2. So you now have y is equal to minus 1/2 x plus 2 minus 3. Finally, you get y is equal to minus 1/2 x minus 1. Okay. So that's just substituting. So like you're trying to substitute previously to the value of x and the y and those kinds of things. And then last way of finding the equation of a line is we call it 2-point formula. This is happening when you know 2 points of a line. Okay. If you know 2 points of a line, then you can use the formula y minus y sub 1 equals y2 minus y sub 1 over x2 minus x sub 1 times x minus x sub 1. If you know 2 points, all right? Or, yeah, you can also use the y sub 2, x sub 2, y sub 2. As long as if you want to use y sub 2 here instead of y sub 1, just be consistent with your putting in of the x sub 2 in here. So it's either y minus y sub 1 equals y2 minus y sub 1 over x sub 2 minus x sub 1 times x minus x sub 1. So we call it the 2-point formula of finding the equation of a line. So I hope this one is clear, but the idea is I have 2 points, minus 2 and 3, 6 and minus 1. So we make substitution, y minus, I want to use the first point, y minus 3 equals. Then you'll have now the y sub 2. So it's minus 1 minus 3 over x sub 2 minus y sub x sub 2 minus x sub 1. 6 minus minus 2, which is x plus 6 plus 2. And then x minus x sub 1, which is x minus minus 2. It's x plus 2. So you now have y minus 3 is equal to, this is 1/2. This is x plus 2. Then y is equal to minus 1/2 x plus 2. So if you have 2 points, well, definitely you're able to find the slope, but we can use the direct formula for the equation of a line. We call it 2-point formula. All right, so just to illustrate this once again, I want to find the equation of the line passing through. So you help me, tell me how to put in all the values. Okay, let's just use this equation. All right. Okay. Yeah. All right. Using the first equation. Yeah, I want everyone to say how will I put? I will put y minus. Yeah, this one, this point, this line. Y minus.
Minus 3. No, sorry.
Okay, we begin. I want the y1. I want to use this formula. Okay. Y minus
4.
4 equals
Minus 3.
minus 3
Minus 4.
minus 4
Oh,
over
0.
0.
0
3.
minus 3 times x. X will stay because we're looking for an equation. Minus
3.
3. Yes, good. All right. So you now have y minus 4 is equal to, this is negative, negative. That will just be 7 over 3, right?
Yeah.
Minus 3 minus 4 is minus 7. 0 minus 3, that will become negative by negative times x minus 3. So I will
Okay.
now have y minus 4 equals 7 over 3x. This will become minus 7, right?
Yeah.
Okay, or 7 times 3 over 3. Okay, if we just want to continue doing that. So y minus 4 is equal to 7 over 3x minus 7, because 3 and 3 will cancel. Final equation, y is equal to 7 over 3x minus, is that 3? Because we
Mm.
transfer to the other side. Yes. Let me just continue. Let me just, so I am doing it. Okay. Yes.
It's
Okay. Let
or
me just, okay. Let me, this one is like, it's very,
yeah, it's confusing.
sorry.
Why?
I'm sorry, I will put the 3 again. So, yeah, let me, okay. So 7 over 3x. This one is 7. So you now say equals 7 over 3x minus 7 plus 4, right? Gives you y is equal to 7 over 3x plus minus 3. So that will now be the equation of our line that passes through 3, 4, and 0, negative 3. If you want to really check whether you get the same answer, if you use the second equation, you can do that on your own and you'll find out that the equation remains the same. Right. Now, for number 2, try doing it. I want you to use the second formula.
I have a question.
Yes?
For me, it was gonna be, I was gonna say, okay, 7 over 3 times what is in the bracket, like 7 over 3x, and then 7 over 3 times minus 3, which is going to be minus 7.
Mm-hmm.
Then it should be like that. Then I transfer the 4
Yeah.
to the other side, so it will be minus 3 plus
Mm-hmm.
4. No, it will be minus 7 plus 4.
Yes. Yes. Yeah. Because this one cancels, right?
No, I didn't. It's that step. I just did it shorter. Like I already came to this one, the last, like 7x over 3 minus 7. Like I
Okay.
can't. I
Then you
multiply.
transfer 4 to the other side, yeah?
Okay, I guess it works. I'll just do it that way.
Okay.
Mm.
Fine now? Mhm.
Number 2.
Yeah.
All right, yes. Passing through minus 1, minus 2, and minus 5, 6. And I want you to use this other formula where you're substituting the 0.2 rather than the 0.1.
Okay.
So this is our 0.1 and this is our 0.2. Just to use the other one, use 0.2 as your reference rather than the 0.1. me just erase this so it doesn't get so confusing with so many. And they get the answer now.
Y is equals to minus 8 over 4x minus 4.
Okay, simplify that.
I got minus 2x minus 4.
Okay. So yeah, you are there as Snake, except that you haven't simplified.
Too easy to make mistakes in this. Long.
Oh, you said it's right? 8. Oh,
Yeah,
oh,
because
okay.
8 over 4 is negative 2.
X minus 4. Minus
Divided by 4, negative 2. So you're supposed to be, your answer will be y is equal to minus 2x minus 4.
yes.
Yes, let's do that together so that everyone can, yeah. So let us use this formula. Okay, tell me what to write. Y minus
6.
6. Because this is what we will be substituting. Equals y2 is 6 minus 2, right? Over
Minus
x sub
5.
2 is minus 5 minus 1. All right. And then x retains minus what?
Minus 5.
Minus 5.
Minus 5, right? Okay. So y minus 6 is equal to 6 plus 2 over minus 5 plus 1. Actually, you don't have to, okay. So now have x plus 5. Some of you can just do things directly. Y minus 6 is equal to 8 minus 4 times, x plus 5. But 8 minus divided by 8 by negative 4 is minus 2. Then x plus 5. So y minus 6 is equal to minus 2x minus 10. So do you have now y is equal to minus 2x minus 10 plus 6, and therefore y is equal to minus 2x minus 4. Is that okay? All right. So those are now the equations of a line of the form y is equal to mx plus b. So in a situation like this, we're saying this one, okay, we are saying, oh, all right. Oh, I'm sorry that Bethany is not feeling well. So we will, yeah. So our slope is -2, and of course, this is our y-intercept. Yes, so we have learned the different equations of a line. Now, what the plan is supposed to be, really, if we follow our schedule, supposed to be, it's today is the midterm exams. Now, as I mentioned, I really just want midterms to be done so that will be out of the way. And then your finals will be whatever we will start discussing this coming after the midterms. So this is what we'll do. I'll give you some exercises on Cartesian plane until this equation of a line so you can practice a little bit. Because the midterm exam would be just some few questions on the previous quizzes. But most of the questions will be really on this present lesson. What we'll do is on Tuesday, we'll begin with review. Okay, so we'll review what we have done so far before we do the midterms so that you can now ask all the questions. The midterm will just be from 45 minutes to an hour. So we'll be having review and then we'll do the midterms. But of course, I will be asking you to do some exercises on the current lesson after the quiz that we had. And I'll ask you maybe to submit by Sunday evening so that I can give you feedback. Or yeah, it can maybe I can even make it as a Monday noon. So I can give you immediately the feedback, and then we'll have review on Thursday. On Tuesday. After review, then I'll give you your midterms. Right? And maybe I can also write on the dashboard, the bulletin board, the review guide for your midterm exams. Okay, so I hope that will be all. Now, before we even leave, I just want to pray for Bethany. I didn't know that she's sick. That's why she decided to stay home. Let us pray. Heavenly Father, thank you so much for being with us during our lesson today. We're sad that Bethany is having fever. I pray that you'll please touch her with your healing hands. Guide her, Father, that she may fully recover soon. We trust you being our greatest physician. And bless each one of us that we may also enjoy good health. Bless the students as they do all their activities throughout this day and even as they do some of their homework and preparing for the midterms this coming Tuesday. We pray in Jesus' name. Amen. Okay. So God bless you. We'll see
you.
you on Tuesday. All right. Yes, let me